For the next presentation, Dr. Krzysztof Tomczuk. He is the leading specialist of the research division of the Electrotechnical Institute of Warsaw. We are happy to have this institute in our ELMAR partnership. The presentation, Hybrid Drive Systems in Gdansk Bay and Tricity Water Transport, presents elements of tourist water transport that exists in Gdansk, Gdansk Bay and Vistula Lagoon. Selected vessels are presented, routes and their propulsion methods are defined. So, Krzysztof, the screen is yours.
Hello, my name is Krzysztof Tomczuk. I work in Electrotechnical Institute in Warsaw, in Poland. Electrotechnical Institute supports our market and our industry almost for 70 years. Now, from last almost 2 years, we are the part of the Łukasiewicz research group. So we are one of the part of the ELMAR project, and I would like to present the presentation of the hybrid drive systems in Gdansk Bay and Tricity water transport. The presentation content is water touristic transport in Gdansk, Gdansk Bay and Vistula Lagoon, length of the touristic transport lines, type of the ship description, hybrid propulsion requirements, description of selected energy carriers, impact on environment regarding the exhausts, exhaust filtering, estimation of hybrid drive parameters on selected ship, and at the last is estimation of savings in fuel consumption and emission exhausts. So, regarding the water transport, touristic transport in Gdańsk, we have two transport lines named F5 and F6. They are presented here on the figure on the color green and orange. First line F5 has 9 kilometers distance in one way, has seven stops. The ship takes 50 passengers and 5 bicycles. During the 1st May and 30th September, there is line is serviced by one ship, and additionally in holiday seasons is another one ship. So during the holidays we have 2 ships. Another touristic line in Gdańsk, there is line F6, which is from Targ Rybny fishing market and to Sobieszewo Island, and the distance is 17 kilometers in one way. And there is also 7 stops, but the line is serviced by the bigger ship, which takes 100 passengers, 10 bicycles. During holiday season, line is serviced by one ship, but out of holiday season is serviced also by one ship, but the identical to the previous F5 touristic line. In Gdańsk Bay and the Vistula Lagoon, we have a connection that is presented on the screen. There are connections from Gdańsk, Sopot, Gdynia, Rewa to Jastarnia and Hel Peninsula, Hel City. The distances in one way are presented on the bottom of the screen. This is not very long distances. The highest distance is from Gdynia to Bałtysk, to Russia. It's almost 90 kilometers in one way. There is also another connection from Krynica Morska to Frombork. This is Vistula Lagoon. This is distance 15 kilometers. As you know, in Frombork, it is one city where work and live Nicolaus Copernicus. So we invite you to take this trip. Daily distances taken by the ships depends on the of course from the distances and number of trips per day. So the longest distance is from Gdańsk city to Hel is almost 200 kilometers per one day. There is of course three trips per day. And the shortest connections is from Krynica Morska to Nicolaus Copernicus city. It's 30 kilometers in 2 ways. Description of ships. In Gdańsk city, there are 2 water tramways called Sonika and Sonika 1, which were manufactured in 2004 and 2005 year. The ships were manufactured by the repairs and exploitation base of fleet in St. Petersburg in Russia. This is not very long tramway, water tramways, powered by the diesel engine at the power of 132 kilowatts, and this engine drives sends the mechanical energy to jet drive to the jet drive. So as I mentioned, we have 2 of that kind of tramways. The bigger Smile was also built in Russia, in Moscow. This is the ship type Moskovsky, built in Moscow in 1987 by the Moskovsky Strudotrielny i Sudoremontny Zawod. The speed of the ship is 20 km per hour. It takes 150 passengers and 3 persons of crew. The ship is powered also by diesel engine, generally by 2 diesel engines at the power 2 times 110 kilowatts, so totally 220 kilowatts. The most popular ship, this is a ship type SP-150. This is a Polish project which was built in 1976 in Gdańsk river shipyard. You will find many of that kind of ships everywhere in Gdańsk Bay, in Mazurian lakes. So this is the ship which has a maximum speed 20 kilometers per hour. Leisure touristic speed is at 10-12 kilometers per hour. Ship takes 270 passengers and is powered also by diesel engine at the power of 140 kilowatts, manufactured by Skoda. One of the most spectacular watercrafts in Gdańsk fleet is a hydrofoil named Merlin II. This is the type rocket. Ship like the other before was as well built in this time in Soviet Union by Krasnoye Sormovo shipyard in Nizhny Novgorod city. The speed of this watercraft is 60-65 kilometers per hour and has 64 seats. The power engine, hydrofoil is powered by diesel engine at the power on 740 kilowatt, and I found that the fuel consumption of this hydrofoil is 150 liters of diesel petrol per hour. Bigger ship which service the connection from Gdańsk to Hel Peninsula is Onyx catamaran, was built in Wisła shipyard in Gdańsk city. Ship takes 450 passengers, has 11 persons of crew, and is powered as well by the diesel engine. So 2 diesel engines at the power of 840 kilowatts. So total power is quite high. During class time, there is a first birth of the electric mobility on the water. This is a proposition to change the old ferry, which has a connection only 100 meters. Yes, only 100 meters. This is on the old town, and he moves the tourists from the left to right bank of Motława River, which, as you know, flows via the old town of the Gdańsk city. During the last years, we had Motława 1 ferry, but it was the internal combustion engine ferry. Now some people decided to change this ferry into a fully electric ferry, powered by the three-phase induction motor and lithium-ion batteries. And here there is a view, the curve of the power consumption via the speed. So as you see, there's kilowatts used, not very high power, but also there is also the high distances. Hybrid propulsion. So what is the requirements for hybrid propulsions? The main tasks of the hybrid is a reduction of the emission of harmful exhaust gases into the atmosphere, reduce fuel consumption, possibility to work in quiet zones where the use of the internal combustion engines is prohibited, and there is only a possibility to operation in electric mode, and possibility to charge the battery from the power grid and from the internal combustion engine. This is, of course, we can find many other requirements, but in my opinion, this is the most important. Selected energy carriers. Here on the screen you can see the values of selected energy carriers given in megajoules in 1 kilogram and in 1 liter. So as you see, that there are completely different values. And regarding the energy stored in 1 kilogram, the winner is the hydrogen. The liquid hydrogen and the compressed hydrogen is the winner. But when we look at the number of the energy stored in 1 liter, the winner is crude oil products, which is right now, and LNG and LPG gases, so that we see that also some kind of drives, propulsion are turned into, especially into LNG, and it happens right now. LPG, it happened from a longer time. So the impact on the environment. Here on the table you have the view, the numbers of the different type of fuels used in to power the internal combustion engines, and it depending on the sulfur content, we can get different pollutants values. As you see, in my opinion, the most interesting is biodiesel, which in all fields are green or yellow, but only in 3 fields are for example, orange, let's say orange and red. This is sulfur oxides, this is dinitrogen monoxide, and black carbon. So for these 3 pollutants, we can think about the filtering methods. As the exhaust purifications is mainly intended to reduce the amount of particulate matter, nitrogen oxides, sulfur oxides, and then this can be eliminated by the diesel particulate filter, DPF filters. These filters are in a diesel trucks right now, diesel oxidation catalyst and continuous regeneration trap. Short description of the filters. The diesel particulate filter eliminates soot particles through the internal capture, diffusion, and sedimentation effects. Standard elimination are in 90%, but there are some structures where we can reach the 99.8%. Another is a diesel oxidation catalyst, which oxidides hazardous pollutants through the catalyst. Hydrocarbons and carbon oxides react with a reaction to form water and carbon dioxide. The third method is a continuous regeneration trapes, and this is the combination of both of the above solution. Elimination of nitrogen oxides is carried by the through of the one of the technologies, so selective catalytic reduction, non-thermical plasma, exhaust gas recirculation, and lean NOx tracks. This is a completely different point of knowledge that using especially the hybrid systems, we must know which system we would like to use, the fuel which we would like to use, and systems of exhaust filtering. So I decided to estimate the hybrid drive system parameters to answer the question, is there any boat, for tourist transportation we can use as a hybrid, or even we would like to get as a full electric solution. So, as I mentioned before, we have a Sonika water tramways, and I decided to look to this ship. Is it possible to make it hybrid or full electric? Please remember that the power of the ship is 132 kilowatts. Here on the screen there are simulation results of the propulsion and the power requirements. Here on the figure is a dependence of ship hull resistance force depending on speed. Below in the table there are results of the simulation. So maximum weight of the ship is 70 tons, maximal speed 12 kilometers per hour, acceleration, deceleration time is 50 seconds, and we have a result. So temporary peak power I've got 45 kilowatts. When I looked before, the power was 132 kilowatts. So this is 3 times of peak power reduction. I've got also the 13 kilowatts, the constant power at constant speed, 12 kilometers per hour. When we make a short summary of the energy for propulsion, we know that distance in one way is 70 kilometers, 12 kilometers per hour speed. During that cruise trip, we have 13 kilowatts of continuous power, trip time, and this is the number of energy consumed during the constant speed. Additionally, the ship has 7 stops, and during the start-up and braking processes, we have additionally 3.3 kilowatt hours. So totally in one way, the ship needs 21.7 kilowatt hour. According to the diesel motor fuel consumption, we got the fuel mass, and according to diesel fuel density, we can calculate that our water tramway takes more than 6 liters of the diesel fuel in one way. So, short review. The ship spends most of the time moving at speed approximately 12 kilometers per hour. Therefore, the hybrid drive will be selected to work in these conditions: constant speed, constant power, number of courses per day. Daily we need more than 130 kilowatts of energy. The peak power motor 45 kilowatts, and electric continuous power is 15 kilowatts. When we make calculation of the fuel consumption during one day, 1 month, and 1 season, we can calculate that during the one touristic season there is consumption almost 5,900 liters of the fuel. When we look at the number of the pollutants emitted into atmosphere, so according to the table I presented before, we see that the carbon dioxide is 660 kilograms, NOx 1.5 kilogram, and other pollutants are presented here in the table. So what is the solution? Hybrid or electric drive? I decided to use the full electric solutions. So I decided to look at the battery from BMW i3, but the strongest version at the capacity of 120 ampere hour, with nominal capacity of 42.2 kilowatt hour. As we know, the capacity of a battery is calculated by very low discharge current, that the influence of internal resistance of batteries are very low. That's why we've got very high capacities. In normal life, the useful capacity range when we use the higher currents are lower. In this particular conditions is about 5 kilowatt hour less. So the capacity is 37.5 to 39 kilowatt hour. We know as well that the fast charging region is in the constant current region, which is from 0 to 80% of the capacity of the battery. So maximally we can take 30 kilowatt hours from battery, and we applied the DC charging power at the level of 49 kilowatts. The charging time is 37 minutes, but this is from 0. But in our conditions, when the ship finished trip in the final stop, in battery is remained 22% of energy, and we must charge it from 22 to 80%, so it takes 27 minutes. When we look at the timetable of our water tramways, we can see that there is no time for charging during stop time. There is only one way when the water tramway stops 45 minutes, so this is not enough time for charging. The time should be extended, and the chargers should be placed at the end stop. So the conclusions, at the present moment, almost of the ships are powered by diesel engines. Because of the acceptable cost, exploitation cost, usage of LNG, CNG, LPG gases looks to be good solution to power supply the engines. Additional improved exhaust filtering, DPF, DOC, CRT filters should be applied to watercrafts. The use of electric and hybrid ships for water transportation is possible after meeting the following requirements. High-speed energy chargers should be placed at the first and last stops, increase the time for battery charging, and the last, I think in my opinion also as well very important, verify maximum speed and acceleration deceleration values. The hybrid and electric drive and way of use it, we must also verify very strongly. So this is literature. So thank you for your attention.
Thank you for your presentation, Krzysztof. Sorry for the pressure. I know it's hard to give these informations in such a short time.
Yes, I'm on time. No, 2 minutes. I extend.
Yeah, a little bit over, but it's okay. So if I can see, right, we have one question, isn't it, Liana and Romy?
Yes, so we have a question about the peak power that is needed in the ship. I mean, if you have a storm situation, a wind situation, don't you think, that is the question, do you think that probably more than 45 kilowatts are needed for the hybrid ship, maybe?
You know, the peak power depends on the acceleration and the deceleration in this solution. From the deceleration values, yes, of course, the wind speed which blows in opposite way to the direction of the speed also has a very big influence. But as you saw the ship is not. I will present it once again. The ship is not very high, So do you see? This is the tramway. This distance is maybe 2 meters, and the surface, the front surface as well is not very high. Please remember that the tramway operates in the city region, so the wind speeds are not very high. So dependently, in original way, the speed, the power of the engine was 132 kilowatts, but the influence is that the ship was much more rush, they had better acceleration, better deceleration. But as I mentioned, we must review the operation way of the ships during using the electric drive or hybrid drive. We will never get that kind of very good operations like on the diesel engines. But this is my point of view. I'm not sure you agree with me.
Yes, thank you for. I hope that answered the question. That was not the question for me. Yes, and we got the thank you for the answer from the person asking the question. I have also a question about the emissions. I mean, you very nicely take into account all the different individual emissions for the diesel engine. However, a battery also has emissions, not during the drive. There's no local emissions, but there are, of course, global emissions while the batteries are produced. Do you take them into account as well, or do you only care about the local emissions?
Yes, I agree with you that we must supply the energy from somewhere to charge the battery. But in power plants in Poland, I think in Germany or other European countries as well, we have a special filters for a reduction of sulfurs. We have a special filter to reduction of any dusts. And as some time ago, I spoke to one of the biggest power plant powered by coal in Poland, in Bełchatów, and he told me that 99.8% of any pollutants except the carbon dioxide is taken in the any capture processes. So yes, I agree with you that this emission turns into the change into the power plants, except the carbon dioxide. Yes, because at the present moment we don't have any installation to capture the carbon dioxide. I think only the greenhouses, the plants production. This is only that's my answer.
Yeah, thank you. No, that was a very good answer. I mean, of course, we're talking about the sulfur and the dust and things like that, but carbon dioxide also is very important. And if you're using coal as the main energy source for the electric boats, then it's difficult. But I guess we are always talking about mainly green electricity at some stage. So thank you very much for the interesting talk. And I think we should look at the time and keep our discussion to one of our next meetings as well. Thank you so much, Krzysztof.
Thank you, Johannes. Thank you.